Welcome back. We are going to solve a problem for question 22. 22, these are the problems. It's mostly about integration techniques, and we are going to solve every problem that is here. So let's go to start for the first one. The first one is say, do the integral of 1 plus 6x to the 4 plus multiplied by 6 ddx. What is the technique here? The technique here is called substitution. If we name 1 plus 6x like u, so this is u, ddu, the derivative of u respect to dx is 6, because the derivative of 1 is 0, the derivative of 6x is 6. So ddu is 6 ddx. So you see, c ddx is sitting down in front of you. So this is ddu, and this is u raised to the 4th power. So the integral is the integral of u raised to the 4th power ddu. And this integral is u raised to the 5th power divided by 5, applying the power rule. Now the problem is not solved yet. You cannot stop here. You have to keep going. What is u? 1 plus 6x. So you read again, is 1 plus 6x raised to the power 5 divided by 5 plus c. So this is the final solution. Again, you can differentiate this expression, and you will obtain the integral 6 times 1 plus 6x to the 4th power. Okay, you can try. Next one is to make the integral of 25 minus x squared multiplied by minus 2x ddx. The technique is to realize what is ddu. Ddu is here and is sitting down in front of you if you name u as 25 minus x squared. If you name u like 25 minus x squared, the derivative of u respect to x is minus 2x. So ddu is minus 2x ddx. ddu minus 2x ddx. Perfect. So ddu is here. And here you read it as square root of u. So the integral that we have to do is the integral of a square root of u ddu. This integral, we apply the power rule. So it's u 3/2 divided by 3/2 plus c. And the problem is not solved yet. It's 2/3 of u to the power 3/2 raised to 3/2, but the problem is not solved because you have to put what is u. U is 25 minus x squared. So the solution is 2/3 u 25 minus x squared raised to the power 3/2 plus c. And the second problem is done. Let's go to the third one. The third one is this one, square root of t multiplied by square root of t squared plus 2. You need to define who is u in a way that t ddt will appear like ddu. If I define u like t squared plus 2, ddu is almost sitting down. It's 2t ddt. So t ddt is ddu divided by 2. So now I will read this equation again. T ddt is ddu divided by 2. So ddu divided by 2. And here it says square root of u t squared plus 2. So the equation will read square root of u 1/2 ddu. Now you make again the same thing. You apply the power rule. It will be this expression, and the problem is not finished yet. The problem is finished when you substitute the value of the variable u. The value of the variable u is t squared plus 2. So it will be 1 half, 3 half here, it will be 2/3. 2/3 u t squared plus 2 raised to the power 3 half plus c. And if you cancel the 2 with the 2, will be 1/3 t squared plus 2 raised to the power 3 half. Let's go to the next problem. Again, you need to find who is u in a way you can identify ddu. So in this problem, I will choose u to be 1 minus x squared. Why I will use to be u equal 1 minus x squared? Because ddu, or the derivative of u respect to dx, is minus 2x. So ddu is minus 2x ddx. And now I see x ddx here sitting down in front of me. So x ddx is minus ddu divided by 2. So we go again to the equation and we rewrite the equation in terms of u. X ddx is minus ddu divided by 2. And 1 divided by 1 minus x squared to the raised to the power q is 1 divided by u cubed. And again, we do a little bit of algebra, we apply the power rule, we express u 1 divided by u to the third power like u minus 3, we apply the power rule. Once that we apply to the power rule, the expression is finished when we substitute the u by his value, 1 minus x squared. So the final result for this integral is 1/4, 1 divided by 1 minus x squared, everything square. And you can derive this expression, and you should find this expression, the integral. If not, it's because I made a mistake. Okay, the following problem. So we focus that if we choose u equal 4x, ddu will be 4. ddu will be 4 ddx. ddu respect to ddx is 4. So ddu will be 4 times ddx. I don't see the 4 here, but I see ddx. So the ddx is 1/4 of ddu. If you solve for ddx, ddx is 1/4 of ddu. So now I will read my equation. Sine of 4x, sine of u, because I have chosen u to be 4x, by ddx. ddx is 1/4 ddu, 1/4 ddu. The 1/4 go out of the integral, sine of u ddu. You know the sine of u is cosine of u minus cosine of u. The integral of minus sine of u is minus cosine of u plus c, so it will be minus 1/4 cosine of u. And again, you have not finished until you substitute the value of u for his value, 4x. So the final answer is minus 1/4 cosine of 4x. And again, you can differentiate this expression to obtain the integral. Okay, let's go to the next question. The next question says find the integral tangent 4, tangent to the power 4, secant squared. So what is the technique? The technique is, if I choose u to be tangent x, I know that the derivative of u respect to x is secant squared. So it will appear secant squared here. So ddu respect to dx is secant squared. So this means that ddu is secant squared ddx. It means that here, this part is ddu, and this part is u to the 4. So the equation will be u to the 4 ddu. Power rule, u to the 5 divided by 5. Substitution, u is tangent, tangent of x raised to the power fifth divided by 5 plus c. And again, you can differentiate this expression to obtain this integral. Let's go to another question. 1 divided by a square root of 2x plus 1. You need to redo this problem several times until you get the practice how to do it in a way that when they ask you a similar problem, you know what to do. So now we choose u to be 2x plus 1. If we choose 2x, why we choose 2x plus 1? Because the derivative of u respect to the x is 2. So d du is 2 times d dx. So d dx is sitting down here, is d dx. Then d dx is 1/2 of d du. So I will go again to my equation, to my original equation, and I will replace square root of u by d du divided by 2. 1 divided by u raised to the power 1/2 by d dx, 1/2 d du. And this integral is easy to do it because you know the power rule. So it will be 1/2 u raised to the power minus 1/2 within 0 and 4. Oh, this is one detail. It say x equals 0 to x equals 4. But if you choose x equals 0 and you choose u to be 2x plus 1, it means that when x equals 0, u is 1. And here it means that when x equals 4, u is 9. So the integral is from u equal 1 to u equal 9. So you do it, and the result is 2. Okay? It's interesting that we change the shape of the function, but the area is the same area between x equals 0 and x equals 0 and x equal 4 of this function, 1 divided by the square root of 2x plus 1 is the same area below the curve that the area below the curve of a square root of u between u equal 1 and u equal 9. The function has changed, but the area is the same one. Okay. I think this is the last one. I hope so. This is the last one. No, it's the 8th. So we have another problem. It says cosine of 2x divided by 3 d dx. What you will do, you will choose u to be 2x divided by 3. Why? Because if u equal to x divided by 3, d du is 2/3 d dx. d du, the derivative of u respect to x is 2/3. So d du is 2/3 d dx. So the 2/3 doesn't appear here, but it appears the d dx. So the d dx is 3 divided by 2 d du. So when I see d dx, I will replace by 3/2 d du. So the equation, the integral will be this integral from x equals 0 to x equals pi divided by 2. It will be the integral, because I have chosen u to be 2x divided by 3. When x equals 0, u equals 0. And when x equals pi divided by 2, u is equal to 2/3 of pi divided by 2 or pi divided by 3, because this will cancel. Okay, so the integral will be from u equals 0, from this u equals 0 to u equals pi divided by 3 of cosine u d dx, 3/2 d du. doing the integral is easy. 3/2 go outside the integral. The integral of cosine of u is sine of u. Sine of u evaluated between 0 and pi divided by 3 is sine of pi divided by 3 minus sine of 0. Sine of 0 is 0. So the final answer is 3/2 sine of pi divided by 3 is square root of 3 divided by 2. So it's 3. The final answer will be 3 square root of 3 divided by 4. Okay, let's go to the next problem. Evaluate the integral using properties of even and odd function. A function is even when f of x equal f of minus x. This means that whatever you find in this x, the h that you find in this x, f of x, if you go to the point minus x, the point that is exactly in the opposite side, minus x, the value of the function is also f of x. So the function is symmetric with respect to the y-axis. This is an even function. And an odd function is the function where f of x is minus f of minus x. What does it mean this? It means that you choose a point x and you see f of x of the point. You go now to the point minus x, the one that is in the opposite side, minus x, and the f of minus x is equal minus f of x. Wow. So f of minus x is minus f of x. F of x is positive, minus f of f of x, f of minus x is negative. So the function is an odd function. For example, x cubed is an odd function. Okay? So let's go to do the problem. So the problem is say, find the integral from minus 2 to 2. From minus 2 to 2. Because this function is even, why I know that it's even? Well, let's go to prove it. F of x equal x squared multiplied by x squared plus 1. Let's go to see who is f of minus x. F of a minus x is minus x squared multiplied by minus x squared plus 1. But minus x squared is equal to x squared multiplied by x squared plus 1. So I have proven that f of x is equal f of minus x. So if I found a function who is an even function, the area that is here and the area that is here is the same area. So I can calculate the area from 0 to this point x and multiply by 2. So I will have the area from minus x to x, or from minus 2 to 2. So the area of minus 2, from minus 2 to 2 of this function, because it's an even function, is 2 times the area from 0 to 2. The area from 0 to 2, well, it's the power rule, and you make the calculations, and that's all. No big deal. This one, it say evaluate using the property of even and odd function. So we need to see if this function is even or odd. Let's go to see it. F of x equals sine of x, cosine of x. Who will be f of minus x? Will be sine of minus x multiplied by cosine of minus x. But sine of minus x is minus sine of x, and cosine of minus x is cosine of x. So f of minus x is clearly, f of x is clearly minus f of minus x. So the function is even, and the area between two symmetrical points, minus pi divided by 2 and pi divided by 2, is 0. So the area is 0. If you don't believe me, you do it, the integral. So to do the integral, you use this expression. Sine of a plus b is sine of a cosine of b plus sine of b cosine of a. So sine of x plus x is sine of x cosine of x, sine of x cosine of x. So a is x, b is x. So is 2 times sine of x cosine of x. So sine x cosine of x is 1/2 sine of 2x. So instead of doing this integral, you do this integral. And if you do this integral and you use substitution with u equal to x, you can see clearly, you can calculate the area, and the area is here, is being calculated here, and the area is 0. Okay?